Hello and welcome to this episode of our TechBytes webinar series. My name is Stuart Green and I'm one of the security engineers working with channel partners in the UK. Today we're going to be looking at automation with the R80.20 API and how easy it can be to write a few scripts to overcome some otherwise difficult or laborious challenges that you might face if you were to do things manually. The use case we're going to look at today is creating dynamic objects to represent Microsoft Office 365 IP addresses, which, according to the customers I've spoken to at least, are known to cause quite a problem when it comes to using static objects in a rule base. The problem with Office 365 being cloud-based is that the IPs and resources used to host it change quite dynamically. And if you're not using some of the more up-to-date dynamic features within your security policy, such as the dynamic objects, which address exactly this problem, we'll ignore that for now. We're going to do things manually with the scripting side of things, but these objects change quite regularly. So if you were to have a policy that had 10 or 20 objects in that represent the IPs for, say, Office 365, you'll probably find that it would work perfectly well one day, and then Microsoft will change something. In a couple of days, certain requests will stop responding, and then given a week, a month, however long it takes for all the IPs to change, possibly, nobody can connect to Office 365. You have to go in, manually update all the IP ranges, update the policy, and push policy out. With some basic automation tools, hopefully we're going to demonstrate how easy it can be to pull in an external source, consume that in an automation workflow, and then push that into your checkpoint security management policy. Bit of a disclaimer, as I mentioned, this functionality does already exist in R80.20, so there's no reason for doing this other than pure curiosity and to kind of learn a bit about automation and how to use things like Python and Postman. In R80.20 we do have updatable objects which address this exact problem, so if you're not interested in putting a bit of work in and doing a bit of self-learning, you can use this functionality already in R80.20. So what are we going to use? We need to use Python 3.7. It doesn't have to be 3.7, you could use 2 if you really want to, if you've got other tools that use Python 2 and you've got tools and modules written already for that version, that's fine. There's no reason to go with one over the other in this case. We're going to use PyCharm as an IDE. Again, not essential, but if you're using a nice IDE, it can make your script and your code development a lot easier because you get some nice tools for collapsing code and debugging and searching for errors, making sure your variable names are consistent, things like that, which if you're doing a basic script you might not see the value of straight away, but once your script or your code grows they'll definitely become a lot more useful and save you a lot of time in the long run. And we're going to use Postman. So Postman, if you haven't encountered it already, is a great tool for interacting with web APIs. You put in where you want to send the API request, put in the parameters of your request, click go, and it will send the request, it will get the response, display it nicely for you, and then you can modify them, reuse them, and even copy and paste them into other programming language at the click of a button. So if you've written your request in Postman and then you want to transfer it out to Python, you click on code and then you can get a nice snippet of what that request equivalent is in the language that you want to transfer it to. Of course, we're going to need a management server to send our API request to. I'm using an R80.20 standalone deployment virtual machine. I'm using VMware, but it works in VirtualBox, ESXi. You could run it in Azure or AWS if you want to. If you're using less than 8 gig of RAM, make sure that you've manually enabled the API and that you've allowed it to accept connections outside of localhost. So by default, it's only going to accept connections from localhost. So if you were doing an SSH tunnel, that would be fine. Otherwise, you need to change that option. So to change that, go into Smart Console, Manage and Settings, Blades, Management API, and then tick the box that says All IP Addresses. Make sure Automatic Start is on as well, unless you manually want to start it. Once you've done that, you'll get a pop-up warning saying that you must restart the API manually. For that, log on to SSH and run API space restart. After a couple of minutes, you'll get everything showing as started. The API readiness test will be successful, hopefully, and you'll see that this will change from require 127001 to require all granted. At this point, we are ready to go. Okay, Now we've got all of our tools installed and things that we're going to need to interact with the API, let's log on to our local machine. In my case, it's a local machine. For you, it could be running in a lab, it could be in the cloud, it could be anywhere. As long as the API is up and running, we're fine. We'll log in. I'm in expert mode. It doesn't have to be in expert mode. It could be in standard CLIS shell, but you need to run API status. Check that everything's running. Management server's running. API readiness successful. That's good. And we can see that it's changed now to reflect that I want connections accepted from everywhere and not just from localhost. That's all good. So let's have a look at the API documentation. The general workflow is when you're working with the API, first you need to log in. Logging in is where you provide your username and your password or certificate if that's what you choose to do. For production environments and any heavier use of the API, I'd recommend using a certificate rather than having hard-coded passwords sitting around in config files. That's just a bit of a best practice. You don't want anybody stumbling across your passwords, especially not if you're using something like Git or GitHub. You might end up pushing your production password up to the cloud for everyone to see, which is a pretty awful idea. So we'll not do that. When we first interact with the API, what we need to do is create a session, and for that we use the login action. Very simple. You send it a login request, you send it a username and a password. If it's successful, it will reply back with a session ID. That session ID is what you then use in any further requests against the API. So let's say you wanted to add a host. You would go for add host, find that in the documentation, and it says here you need to supply the session ID as a header. We'll have a look in Postman at how to do that. Very simple. You just take it from the first request after a successful login. From there, once you've done something, be it add a host, delete a host, add a rule, create a service, you then need to publish. So you've logged in, made your change, you publish. The publish action is very simple as well. It's just /publish. There's no parameters that you need to provide here apart from the session ID. That will be standard for anything you're working on in any particular session with the API. Once you've published, you can log out if you want to. That would terminate the session. Again, best practice so you don't end up with hundreds or thousands of sessions running concurrently with nothing going on in them. So log in, do your work, publish, log out. Fairly simple. Let's have a go at sending our first request to the API. So we're going to use Postman. When you first log in, you'll get something similar to this. You won't have all of the requests configured like I've got here. This is just to save a little bit of time. Nobody wants to watch me typing. So first we've got our login action. We need to set the type to post. You've got loads of methods in here. For the most part, you're going to be using post. If you're interacting with other things, you might need get or put. For the Checkpoint API, we're mostly going to be working with post. We need to fill this in here for the URL. We need to put in the IP address and the port that your API is listening on. And we need to make sure you've got /web_API, the correct version, and the action. We're going to look at the login action here. So we need to go to body. We need to set the request type to raw, meaning that it's not one of the other types that you can pre-select. And then we're going to select JSON/application. All of the Checkpoint API interactions are in JSON format. At least they're going to be for what we're playing with today. So once you've set that, give it a username and your user. The user must have API permissions, otherwise it's not going to work. And the password. For here, I'm using the super secret Checkpoint password that we use on every training course, so nothing to worry about losing here. Once you fill that in, we send it to the API, and hopefully we'll get a session ID come back. So here we get a UID, which is the unique identifier for this session. The session ID is the actual token that we need for further requests though, so we're going to copy that out. And here I've got another request pre-set up. I will put the session ID into the value of this header. Under the body, I've got the values that we need for adding a host. So at the top here under the URL, we've changed it from /login to /add_host. Again, this is all in the API documentation. If you want to go here and get some examples on what requests you need to send, you can search for your relevant command. If you click on request at the top, it will show you what parameters are needed for that request. So here, name and IP address. This matches up with what I've got configured in Postman. I'm going to create a host called my new host, give it the IP address 1234. What we'll do in the background is we'll just load up Smart Console so you can see we haven't got any hosts configured currently. Let's send this request. So we're going to send that. Hopefully that will succeed. and that will give us the parameters, including the UID, which is quite important to pay attention to. We'll need that later on when we're doing some more involved things using Python. For Postman, we can ignore that for the time being. But you'll see all the parameters that come back for the object that was created, some familiar looking things, color, the icon, when it was created, when it was last updated, and who created it. All we care about is that it's come back and that it was successful. You can get that from the status code here as well. So we've created our host. Notice that it hasn't appeared in Smart Console. This is because we've only created it in our session, we haven't published it. So the API follows the same workflow as it does within Smart Console. You create something and then you publish it, at which point if you have multiple administrators working, the other admins will be able to see that object once you've published it. So we'll move on to our next request, which is publish. You don't need to provide any parameters apart from the session ID. So let's check that matches. It should do. Let's put that in here. It matches, that's all good. We will send that. That's published. You get an ID back for the task, so if multiple things are happening concurrently, you can keep track of the status of each of them using a separate API query. We're not going to worry about that now, but be aware that that feature is available, and you can do that if you want to. And if you're paying attention in the background, you'll see in Smart Console, we've got a new host appear with the IP address of 1.2.3.4. Great, so that all works. Before we log out, we don't actually need this host, so we're going to send one last call to delete it. Delete host, name of the host. In this case, I'm using the name of the host. If you're doing anything programmatically, I'd recommend getting the UID of the host and using that. It's possible that the object you're referring to by name might not be exactly what you want to refer to. So let's say somebody logged into Smart Console, changed the object, changed the name, or renamed something that matches the name that you're using in your script. That might not be exactly what you want to delete. So moving a bit further forward, it's best to interrogate the rule base using the API, get the UID for the object you want, and then use that to delete or modify the host later on rather than the name. The name, while you shouldn't have any name conflicts, it's best to use the UID for that because that's never going to be in conflict. So for this case, we'll go against everything I've just said and we will delete it by hostname because it's a little easier. We will send that request. Let's just check the header is the right one because I've done a few tests here. That's all fine. We'll send that. Got the status of OK, that's deleted it. Got a nice message to say it's deleted too. You can see the object's been locked in Smart Console, meaning that something's going on with it. We'll go back to the publish action. We'll get a new task ID, and very shortly that should disappear. Right on cue. Perfect. We'll have a new action now. We'll change this to logout. Don't need to give that any parameters. Send. And OK. What that's done is that's logged us out, it's destroyed the session, so anybody that tries to authenticate in the future with this session ID, those requests will fail. We can prove that if we go here to delete the host. We're still using that session ID, which is now invalid. We'll send that, and we should get wrong session ID. Perfect. We've logged out, we've tidied up, practicing good housekeeping. That session ID is now invalid, so if you use that in your code, if you use the logout action in any of your automation scripts, once the logout has been generated successfully, that session ID is terminated. There's no references to that elsewhere, and you can't use it again. Now we've seen how easy it is to work with Postman and get a feel for how the API works and what sort of commands you send and what sort of responses you should expect, we want to move from Postman into Python. So Python's going to enable us to wrap a lot more intelligence around these requests and not just send requests and get basic responses. Going back to our use case for this demonstration, getting the objects from Microsoft, the IPs that relate to the Office 365 services, we're going to pull in lots of different information, put that into a Python script, and then have that talk to the API using the information that we've pulled in from an external source. So if you've never worked with Python before, it's relatively easy to pick up, provided you've done some sort of programming or scripting in other languages. One of the really nice features about Postman is if you've got your request written in Postman, so let's take the login example here, you can click on code and it will give you code snippets for most popular languages that you might want to write some script or some automation workflow in. So what we've got here, we're going to go for Python. There are two versions. You can use the http.client method within Python 3, or the one I'm more familiar with is the request module. So we'll go through requests. We will copy all of this chunk, and let's move to PyCharm, our Python IDE. I've created a project to organize this code in, but you don't have to do that. You can just create one flat Python file. You don't even have to use an IDE. You could use your favorite editor, Notepad++, Vim, Vi, Atom, whatever you want to use. It doesn't really matter. As long as it's something you're comfortable with and you're familiar with how that environment works, that's fine. So we'll take that code, we'll put it in here. One thing that Postman doesn't copy across if you're using requests is that by default the request module will validate HTTPS certificates that are in use, and as the management certificate is typically self-signed, this will error out. So we can try this now. If we've got our code in there, we'll run. That will come back with an SSL error. SSL certificate validation failed. That's expected, that's fine. We just need to add an extra parameter into the response line, verify equals false. Now once we run that again, all things being well, we should get pretty much the same output that we get in Postman. So we get the UID and we get the session ID. We can take this and we can build our Python code around this, put more API requests in, take in some external data from Microsoft, process that, and then use that to generate more API calls back to the management server and create the objects based on the IPs that we've pulled in. After a small amount of video editing magic, you'll see that our simple code has now grown a little bit. Don't be put off by how much there is, it's not that complicated. So what we have done is we've taken our basic code structure that sends an HTTP request to the API, and we've broken it up into different sections to make it modular. By making it modular, we can reuse that code later on once our automation project grows and expands into something a bit more complicated. So what I'll do, I'll walk through each of the sections and each of the bits of code on here to explain what it does and why we've chosen to do that. So if you're not familiar with Python or programming, this might be a little bit heavy. Bear with me. Hopefully you'll be able to follow the structure of how it works and either copy it completely, modify some of the values, or understand it, take it, build on it, and put that to use in your own automation script. So we start with the imports. Imports in Python are a way of bringing in extra functionality. So here we're importing the requests and the JSON module. Requests is the module that we use for handling HTTP requests. JSON is the module that we use for converting strings and objects into and from JSON formatted text, which is what we're using for the Checkpoint API. This line isn't super important, and in fact it's a bit of a fudge to make the output a bit clearer. This is hiding all the warnings where we've turned off SSL certificate verification. Next, we create a dictionary to store all of our parameters. A dictionary is a key value data structure in Python, and you can see here we've broken it up into different sections depending on what that value is and what it is in the URL. So we have the IP address, the port, the scheme, the version, the path, username and password. So fairly simple, a few lines of code. Then we have the class. This could be a little bit difficult to comprehend if you're not familiar with object-oriented programming. What a class is essentially a cookie cutter for some functionality that you're going to reuse elsewhere. So the example you tend to get in lectures and online tutorials is the class is a factory, and when you want something new from that factory, you want an object that is a car. So you would say, from that factory, I want a new car. And that car will inherit certain values and certain functions because it all comes from the same mold, the same reference object. So what we're defining here is that when you create an object of this class, it's going to take all of the parameters that we've given it to start with, convert these into a URL. That URL is going to be where we send our API request to. So you can see here we're putting together scheme, IP, port, path, and version. We're missing the command off because we're going to specify that separately. But when you put all those things together, that's going to give you something similar to this. So you see, we've broken it down into its component parts, and using Python, we're going to rebuild it again. You might think that's a waste of time, but if at any point we want to change the IP address or the port or the username or password, you don't have to rewrite this whole chunk of code again. You only have to rewrite one of these variables. So again, this is making things more modular and therefore reusable in the future. Next, we need to create another dictionary, another key value pair, creating the headers that we're going to send in our HTTP request. Here, all we need is the content type set to application/JSON. If you remember, we did that in Postman as well. We're doing the same thing in Python. Next, we are creating the payload, or the body that we're sending with the HTTP request. So we create a variable, in this case, rec_data. We're putting in there user and password, and we're passing these through from the original parameters that we've specified here. So when you create your class object, you pass the parameters to that, they get passed into here, and they can be reused when we send the HTTP request to the API. Bear with me, we're almost there. So the request data, we then need to format that as a JSON string rather than a plain piece of text. This makes sure that it's laid out correctly in a way that the API can understand. Then we say we want to prepare an HTTP request, and we're going to add the login command to our URL. Remember, we've constructed the URL here using the parameters that we've specified here. So everything should start to make a bit more sense now. We're going to pass that in, we're going to give it the login command. The data, this is the payload or the body that we're going to send with it. This is what we've specified here, so the username and password. Headers, they're the login headers. This is the content type declaration that we've made. And for testing, we've turned off SSL certificate verification. So at this point, the request, it's all been bundled together. You've got the right URL, you've got the username and password, it's all formatted correctly. Now we can send it to the API. If the API responds with an HTTP status code of 200, meaning OK, you'll also get the response that we had earlier. Let's have a look in Postman. So it would have been something looking like this, where you've got the session ID. We don't need the other information for now, just the session ID. So we're going to take apart the response that comes back. So the response is going to be in JSON format. So we're taking the response text, taking it apart, putting it through the JSON parser, the JSON decompiler if you want to call it that, and we're extracting the session ID. Then we're going to add to our object, which is part of this checkpoint class, we're going to add the X checkpoint session ID header to that. So for any other request we make, we've got that and we don't have to add it manually. We've done the hard work once, we're storing it, and then we're going to reuse it for all our other requests. A little bit of error checking, which is always good and helps to make your code more robust. If we don't get a status code of 200, so we get a 500, say the API is not started, or we get a 400 or a 401, something like we've got the password wrong or the API isn't ready, then we'll get an error code and the code will quit. So we're saying print an error and then exit. After that big section of code, hopefully you're still with us and following, we've got three somewhat easier to understand functions built into our class. Send command, this is a basic wrapper for sending other commands to the API. So all you need to do in your code later on is specify send command, what the command is, and what data you want to send to it. So in this example it's add host, and the data is going to be name, my host, IP address, the IP address. Then we've got a publish function, which doesn't take any input, it just sends the publish action, and we've got a logout action, which is going to send the logout command. Fairly simple, those don't take any inputs, they're just housekeeping, and if you remember us talking earlier, they'll publish any changes and log out and then destroy the session. So that doesn't exist anymore and can't be used or abused elsewhere. So the send command, this is the one that we're probably going to use the most. What we're doing is we're building another HTTP request. Again, it's a post, it's going to the URL. We're simply adding the command that we send to this function at the end, providing the data, the headers, so the auth header, the XCHKP SID that we've got already from the logon procedure. And again, for all of these, we're not doing SSL verification because it's testing. We don't care about that. So After all that code is written, you don't have to worry about writing that every single time you want to do something. You create an object out of your class that you've written. So here we're saying my test equals an object of type CPAPI. We're giving it the management parameters that we defined right at the start of our section of code. That will go through. Once you've sent it the parameters, it will go through this initialization function, connect to the API, get the authorization header. If it has an error, it will give you the error and it will exit, it will terminate. If it's fine, it will continue running. In this case, all we're doing is we're adding a simple host. So we're saying create a placeholder for my data, name, my host, IP address 1234. Then we use the send command function within our class. The command is going to be add host. The data is going to be this part here that was specified. Send that, and the reason it's in print is because the command itself will provide a response back to you, and we just want to see that response. In a normal workflow, you wouldn't really care about that. You'd do some checking elsewhere, but what this is going to do now, we will see when we run it. So it all happens quite quickly. If you keep an eye in the background here, you should see the host appear. Very quick. So it's gone in, it's logged in, it's sent the command, it's published it, and it's logged out all within a couple of seconds. So that's taking the basic example from Postman, expanding on it a little bit or a lot, depending on how much you like Python, and we've converted that into a modular Python script that we can expand on and now bring in our external variables and our external object references from the Office 365 API. So we can take the public IPs that Microsoft manage and that they change every so often, wrap those into this script and say, okay, we're going to check the external source, take all that data in, combine the IP addresses into an object or a group, and push that into our checkpoint policy. About 100 or so lines of code later, we now have a working script that talks to Microsoft, gets the IPs, gets the ranges, does some other stuff to tidy that up and make it a bit more manageable, converts them into API calls to the checkpoint API, and pushes all of the new IP addresses or IP ranges into a group that we can use in our policy. So, to talk you through some of the changes that I've made, we've imported a few more libraries. We've now got the UUID module, which allows us to generate some random number to make sure we don't overwrite existing objects in our policy. And we've imported time because we need to pause for a few seconds while the publish action happens. So one of the nice things about using an IDE like PyCharm is you can fold parts of your code. So once you've written, like we had in the last section, the checkpoint API class, we don't need to worry about that. We've tested that code, or I have, between making the last section and this section, and we don't need to worry about it anymore. That works, so we can hide that out of the way. Now, one of the next functions that was written was the function to retrieve the IP addresses from the Microsoft API. So again, keeping things modular, I've written this as a separate function. This is so you can reuse it elsewhere in the code or elsewhere in another program. Should you want to, at a later date, you can just cut and paste the whole section from one Python file into another. So what are we doing in this function? We are, as the comments will say, comments are really important. I know everyone tells you you need comments. Comments are great. If you don't comment, you're a terrible coder. You do need comments. They're horrible to write. Sometimes it feels like you're writing more comments than you are code. But when you come to pick your code up in a week or a month's time and it's not at the front of your mind, you're going to be really thankful for yesterday you writing those comments in and explaining why you did a strange looking line of code rather than something else. So for saving time in the future and your own sanity, comments are pretty useful. Anyway, back to this function. What we have is we're importing the UID module. This is to generate a UID that we're going to take a section of and use it to suffix our object name. So we're making sure we're not overriding anything which either we've created before or someone else has created elsewhere with another script perhaps. Then we're defining the URL that we get the IP addresses from. This is documented on the Microsoft site if you want to have a look. All it really needs is for you to access that URL and supply a client request ID in the form of a full UUID or GUID. So we're going to, in the similar fashion with the previous requests, we're going to use the request module to send a GET request to that URL, and we're going to give it the parameter that we've defined here. That will give us back a rather large JSON block of IPs with some parameters and some section headers around them. For the purpose of this little demo, we're not going to use all of that. Within the file, you'll see that there are sections for outlook.office.com or office.outlook.com, sorry. Different things for Office 365, protection.outlook.com if you're using their service which provides you with spam protection, threat prevention, that type of thing. All we're going to do for the time being to prove a point is we're going to use the block, the smallish block, that refers to office.outlook.com. So when we get this block back, it will have a number of sections in it. We need to look for the section which starts with outlook.office.com. So we're saying if URL's the value of one of the levels within the block that comes back from the Microsoft API. If it has the section URLs and that section contains outlook.office.com, that's the part we're interested in. So we're going to take that content and we're going to put it into a separate variable, which is going to live outside of this loop. So we're going to look through our response that's come back from the Microsoft API until we find the section that's labeled outlook.office.com. We're going to take that and put that into a variable. The break command, that stops us from looping through anything else in the file, essentially wasting time. So if the first block in that file is the part we're looking for, we don't go through the remaining blocks looking for something that we've already found. Saves a bit of time. It's not a big script, so it's not going to make huge amounts of difference, but if you're processing hundreds of megs or gigs of data, it would really save time if you stop as soon as you found what you're looking for rather than processing everything that might follow it. So now we've got the IP addresses. Those IP addresses also contain IPv4 and IPv6 addresses. If I just drag my browser up, I can show you an example of the data that we get back. So you can see here you've got a number of IPv4 network addresses with subnet masks or mask lengths, CIDR ranges, whatever you want to call it, and you've got a number of IPv6 addresses that we're not going to use. You can use them, you can put them in via the API, but to keep things nice and simple, everyone's familiar with IPv4, we'll use those. So this is the information that comes back. We're going to create an empty list. This is the data structure that we're specifying with the square brackets, and we're going to populate that by iterating through all of the IP addresses that we've returned from the API, including IPv6. So a really simple check is we're going to go through and we're going to look in the value of the IP address, and if there isn't a colon, i.e. it's not an IPv6 address, it's an IPv4 address, and we're going to append it to our list. So that will go through, loop over all of these items in here, one after the other. If it's got a colon in it, it won't add it, or more specifically, if there's not a colon, it will add it in. Then, once we've got our IPv4 address, you'll see that it contains the network address and the subnet mask length inside a format. So we're going to split that up. You could do it on the fly, you could do it later on in the code, but to keep things nice and organized, we're going to split it and create another data structure, which is a list of dictionaries. So we're going to take our IP and subnet combination and split it based on the slash character. So a really simple way of taking this section, that section, away from the subnet section. Not too much processing overhead, not too much to think about. All we're saying is split it based on a slash into two parts. Then we're going to add those two parts in a dictionary structure to our IP CIDR list. So at the end of this function, we're going to have a simple list that has a number of dictionary structures in it. Each of those dictionaries has two values, an IP and a subnet mask. So we can use that directly in the API call to add the network in, which requires an IP address and a subnet mask, or a mask length. So that's the function that we've defined to get the IPs and process them. So all we do is we would then call get _ms _IPs, and that will do all of the functions that we've defined and provide us with a simple list of IP addresses that we can consume elsewhere. So this section of code, this is the same as we've had before. I've added a few new things in here to help us with the next section, which is object group name. So this is going to be the group that we create with the API to put all of our dynamic objects in. An object prefix to make sure we're not creating IPs and overwriting anything else. We've got a suffix, which is going to be random, so each time the API runs or updates anything, it's going to delete the objects in the group, recreate them, and put a new suffix on them, just to be extra sure we're not overriding anything. All these are configurable. All of these are configurable, so if you want to change them or change the name, change the suffix, get rid of the suffix, grab a copy of the code, rip that out, and then change it to whatever you need to suit your policy, your naming conventions, etc. We've also put in some feedback, because otherwise the script is going to run, it's going to sit in the background, and you're not going to know what's going on. So we've put in some little print, call them debug messages if you will, just some feedback, so when you're running the script interactively and not through a part of some bigger automation framework perhaps, you know what's going on. So you're going to run the script and it will say what it's doing. It's setting up the session, it's getting the IPs, adding, deleting. Most of the time the API will respond pretty quickly, but if it doesn't, you know not to worry because it's at a particular stage, it's deleting or publishing, whatever. Some feedback is good rather than a blinking cursor that doesn't give you any idea of what's going on whatsoever. So, to put all of this together now, what we're going to do is we're going to define a variable that is populated with the output from our get ms IPs. So this is going to go off, talk to the API, bring back all this information, strip it out so we only get these sections. We're going to get these IP addresses, strip out all of the IPv6 stuff that we don't care about for now, and just give us IPv4 addresses and subnet masks in CIDR notation. Then we are going to put some data in for our next request, and this is going to check if the group exists before we create it. So with most APIs, it's not going to be as simple as do all of your things like create a load of hosts, create a load of networks, create some groups. You don't know what state that rule base is going to be in. You don't know if the objects are existing. You don't know if the groups exist. You don't know if the group exists with some of the IP addresses. So it's best to check everything first. Now, we haven't taken that to fully comprehensive error checking levels in this script. This is just to get things going. There's some error checking in here just to make it work and make it a little bit more robust. But if you were going to put this into production, you'd want to definitely put in input validation and make sure that any calls to the API are wrapped in error catching mechanism. So for Python, that's try and except. What that means is it will try something. If it fails, it will go to the exception. We can see that here briefly. We've got a try, so it will try something. If that fails and you get an error, rather than the script crashing and exiting back to the command line or back to whatever called that script, it will try the exception clause. So it's like saying, have a go at this. I'm not sure if it will work. I'm expecting there is a situation where it might not work. If that is the case, fall into this section, and then it will do something slightly different rather than just crash. So this helps, again, to make it a little bit more robust rather than just dying catastrophically. Anyway, so what we're doing, we're going to query the API for the group that we've specified here, demo_0365_IPs. We're going to see if it exists. If it exists, as per our comments, again, comments are useful, make sure you use them. We're going to try, so if the result that comes back from this call has a code in it. The code generally means that something's gone wrong and it's an error code. So you see here, if this structure exists in the response and the content of that is generic error object not found, we know that the object doesn't exist and we can go straight ahead with creating it. So we will put a little bit of feedback to say the group isn't found, we're going to create it and add the objects. Now with the Checkpoint API you can create a group, and once you've created the group you can add objects, new objects, and specify that they go straight into a group. So we're sending one API call here using our function we defined earlier, add group, and we're going to give it the name that we specified earlier. Again, we've referenced a variable rather than putting in a direct string there. That object is defined up here, so if you wanted to rename it, you only have to rename it in one place. We create the group, and then for each of the IPs that we have in our list of Microsoft IPs, again we're going to loop through it or iterate through it, which is the official term, and we're going to give some more feedback saying we're adding an object, what the item is, and what the subnet mask is. So we're sending another command of add network because it's a network object rather than a simple host. We're specifying the name, we're giving it the prefix, then we're adding the IP, then the subnet mask, then the suffix, and we're putting some underscores in between. So all this uses string concatenation, which is a fancy way of saying putting bits of strings together. Python could be quite picky about what types you join in. So if you have an integer value, so a number, and a string, it won't always let you put those two together, and you have to explicitly tell them to cast the variable. So represent a string, represent an integer as a string. So for that, you would prefix it with str, put the integer value in parentheses, round brackets, and then that would say, I want to represent this as a string, not as a number. It sounds complicated, and the errors are quite self-explanatory. If they pop up, it will say, cannot cast type X into type Y. If you have a quick Google around that, if it's not something that's as simple as cannot cast integer to string, have a Google for it. There's loads of useful posts on Stack Overflow to help out for that. Anyway, so that's giving the name to the object. Then we're taking the current item in the list, which is going to be the IP. Then we're going to take the subnet mask. These are going to form the properties that we're using in the API call, and then we're specifying the group as well. So we're saying create a new object based on the current IP, the current iterable item in that list is item, that's specified here. Then we're adding that all together, and we're going to send it off to the API. That will create a new network object, and it will belong to the group. That section of code is what will execute if the group is not found. So we'll go straight in and create the group. We have to take a slightly different approach if the group is found and if it's got objects in it. So if the result of this call comes back and it gives us an error saying the group's not there, it will do this. The exception, which is if it hasn't matched that, then it will say the group exists, we need to remove the members from it. So in normal sort of checkpoint fashion, you can't delete an object if it's referenced by a group. It will come up with a warning and say, do you wish to proceed, yes or no. There's a similar sort of workflow for the API. If you try and do something which results in a warning, that will fail unless you explicitly say to ignore the warnings. So we'll see here, we're going to send a command to show group. This is going to get the group specified by name and all of the members within it. So we're saying, just to break it down a bit more, we're taking the JSON reply back. It's a slightly different way of representing it here. So we have the main call here. This is going to result in some JSON. But then on the outside of that call, we're saying in one line, take that result, which is JSON, and decode it or deserialize it. And then of that resulting data, we're only interested in the members section. So what objects and what UIDs are present in that group. Once we've got those, we can check that there's more than 0. So if it's an empty group, we don't need to do anything. If there's stuff in the group, we will get all of the object IDs from that by looping through. This is a bit of a strange function. I did it because it's interesting to see different ways of representing things in Python. This is a map function. So this takes a list, and in a quite a concise piece of code, but it can be quite difficult to understand, it will take that and do something with that data without having to define lots of lines such as we have before, where you have, like you've got here, for something in a group of objects, do something else. It's basically the same sort of structure as this, but in one line. So it can be a bit difficult if you see it and you don't really understand it. The Python documentation is really good, really clear. Again, if it's too technical, too developer oriented, you can have a look on Stack Overflow and somebody will have rewritten it in plainer English. So what we're saying here is we're going to go through the list of objects. Remember, this is the one here that comes back with all the members of the group. We're going to go through, disregard any data that we don't need, because it will come back with attributes, modified time, who changed it, if it's read-only, what the color is, etc. We don't care about that, we just want the UID. So we're going to go through for every object in that list, get the UID, and we're going to put that into a new variable. Then, just to go back to the old structure, no real reason, that's just the way I did it, the way it kind of fell out of my fingers when I was typing it. We're going to go through each of those, and we're going to give some more feedback saying we're deleting the object. We're going to use the UID that we got from this group. We're going to send that in a delete network command, which deletes the network object. Give the UID, and what's important is we're going to ignore warnings. So if you don't specify ignore warnings, the result will come back with a warning saying this is in use in a group. You can't delete it. and when you go to publish, it won't make any changes. So we have to ignore warnings, or you could go through, potentially remove it from the group, but that's a bit more work, and I figure the code's big enough as it is already, so we don't need to make it any more complicated than it really needs to be. Then we've got some debugging here. It's going to print the result of that API call. We actually don't need that, so we'll comment that out. So that will make sure we have deleted all of the objects from the group. Now we've still got the group existing, we haven't deleted that. So we're going to go through our list of IPs that we've generated, which, given the amount of talk, seems like ages ago. So that's the list of IPs with subnet masks at the end, separated into two separate items. More feedback. Again, we're concatenating the different variables and the string together. So adding network objects is going to give you the IP, then the slash, then the mask length. We're saying we're adding it to the group. Then we're sending another API call that's going to add that network object. We've got the data. Again, we're putting together what looks like a fairly horrible piece of code, but this is saying we're going to create an object with the name, 0365 object prefix, then the IP, then the subnet mask, and then the random suffix, and that will be the name of the object. The subnet mask is going to be the network address, the IP that we get. Mask length is going to be the second part of that list, which is the bit after the slash. And then the group we're going to put it in is the group that we've specified all the way back up here. So, all being well, what we'll do now is we'll give that a run. We'll bring up Smart Console in the background so we can see what's going on. We'll go to Networks, we've got a couple of built-in ones. Let's give this a run. Okay, we'll go to Run. We should get some feedback, creating a session, getting the IPs. Group's not found. So it's going to create a group, it's going to add all the new objects we've created, then it's going to publish, then we're going to log out. So once the publish is completed, we should see them appear over here. So you can see they've got the prefix that we specified, they've got a random hex section of a UUID at the end, and if we go back a step, we should have a new group that has all of those IPs in. So if you compare how quick that was, excluding the time it takes to write it, I know that's a bit of a task and a bit of a chore. Once you've got something like that written, that's a one-time task. Every time now that you want to update these IPs, all you have to do is go in and rerun your script. So this is where the benefits of automation become a lot more apparent. You're not having to do things manually, going to the Microsoft site, getting a list of 50 IPs, editing objects, deleting objects, creating new objects, creating groups and adding them all in. This is literally clicking a button that says run. So we've done the hard work once. As programmers, we're kind of lazy. We don't like repeating the same task if we know we can automate it. So we've got our script, we've put the hard work in, tested it. You know, it could be a bit more robust, yes. You can always add more things to more scripts and make them do more fancy things. For now, for the purpose of this demo, I think that's fine. It's relatively robust, it's going to work repeatably, and for doing something that would otherwise be quite a laborious task, this saves us a huge amount of time. So you go in, run the scripts, it will talk to an external service, take the IPs in, consume them, run some basic processing on them to take out any junk that we don't need, and it will feed those into Checkpoint. So we probably won't see now that the IPs will change, because I doubt they've changed in the last 30 seconds, but you can see that the UUID section at the end has changed. So it has gone in, it has done something, it's removed all the IPs, added them back in, and you can see that they've changed. So hopefully you've made it this far and you've persisted through me talking about what is generally quite a dry subject. People either love coding or they see it as, you know, a barrier to getting something done. Once you've played around with Python or PowerShell, Ruby, whatever you want to program in, you realise that these types of languages, they're not as scary as they look from all of the tutorials and the different books and the examples that you get online. The best thing you can do is to grab it, start small, start with a hello world, go through a really simple example, connect to, in this case, the Checkpoint API, add a host, publish, delete a host, publish, log out. Start small and build on it. I didn't start writing scripts that were a couple of hundred lines straight off, unless I'd been on Stack Overflow and borrowed someone else's code. Even in that case, that's not a terrible thing. The open source community is very open and very helpful for the most part, and if there is some code that you can reuse, great, take it, work on it, modify it. Obviously if you're using it commercially, you probably need to attribute it and check what license that code was published under to make sure you're not committing any offences. But generally, code snippets are fine to reuse. It's very rare that you'll find a task that is genuinely unique to you. In this case, have a look on the Checkpoint forum, community.checkpoint.com. Have a look under the, I think it's Coders Hub or Developers Hub. There are lots of people who have contributed various API scripts or PowerShell or Bash scripts or Python scripts to do various tasks in relation to Checkpoint and modifying your rule base through the API. So there's a good chance that if you want to do something relatively common, there's already a script for it. So all you need to do, download it, check that it's safe, I guess, first and foremost, check that it's relevant to your environment, change any variables, IP addresses, password references, that type of thing, and then test it out. Make sure you're maybe not testing it in production, test it on a local VM or a local virtual management station like I have here, and just play with it. The worst that happens is you're going to break a few things in a test environment, but you'll learn from that. You'll learn how different code structures work. You know how to use things like the map function to make your code more efficient. It's a learning process. Nobody just gets coding straight off the bat. You've got to work at it. So don't feel disheartened if your code doesn't work or it takes you a couple of days to get something that feels fairly trivial working. I do that all the time. In fact, there've been bits in here where between the different sections I've been throwing things at the monitor and bashing my laptop in because I couldn't get something simple to work. Go away, have a cup of coffee, come back, and it will probably make a lot more sense when you've had a few deep breaths and calmed down a bit. Hopefully you've found this whirlwind tour of interacting with the Checkpoint API using tools such as Postman and Python interesting and useful. If you check the links surrounding this video, you'll be able to download this code, use it for yourself, take it apart, improve it, take bits out, add bits in, and generally further your knowledge of scripting, automation, and working with the Checkpoint API. Thank you for the time, and hopefully you'll come back for the next TechBytes video.